Hi, good morning. Let's continue our journey of Golang language from the point of view of a C# developer. Today we are going to look at interfaces and how we implement interfaces in Go. Let's start with a C# interface called iAnimal. It's got a couple of it's got a property and a method, and we implement that as a dog and as a cat. And we create an instance of a dog and a cat, put them in an array of iAnimal, and we are able to call methods on that interface type. So if I run it, we get Robo the dog says bark and Tubby the cat says meow. Let's do this in Golang. So first, we need to create the interface. So to do that, it's type animal interface type, and Golang does not have a concept of properties, so we have to use getters and setters instead. So in this case, it's basically only a getter. So let's do a getter. It's called get name, which returns a string, and speak is a method as well, which returns a string. So just on top of that, you will see we are not prefixing animal with I. That's not a convention we are going to follow in Go. And the capitalized G and capitalized ES in the Go interface has significance. A capital initial letter means that element is exported from the package. What that basically means in real terms is if it's capital, we are able to use speak and get name from outside the package main, which is what our current package is. If we don't do that, we can only use these elements from within the cap package we are in. This would be similar to C#'s internal verb, where we can only use within the same namespace. So let's continue. So we have defined an interface called animal, and let's implement them. Again, a crucial difference. Go does not have classes. What we need to do would be to use structs to implement our interface. So let's describe a dog and a cat using a struct type. Dog struct, and it's going to have a name string. And now we need to define the methods of the interface on the struct. To do that, it's similar to a C#'s extension method where we add a method to an existing instance, if existing object. In our case, it will be the dog struct. So let's do that. So to do that, we define a func and d star dog. That's what we are going to extend on or add a method in the Golang. Get name, which returns a string, and return d dot name. And we need to do the same thing for the second method function speak. So func, again we do that on top of dog star dog, speak returns a string, and it returns bark. So here we have defined a struct called dog, added a function called getName and a function called speak against the dog, and hereby, because we are satisfying the requirements of this interface, we have by de facto implemented the interface animal for the struct dog. You see, there's no inheritance. We don't have to inherit it like we did in C sharp. The concept of inheritance doesn't exist in Golang. So this is how you would implement an interface. It's basically satisfying the conditions of an interface on a struct, and you have implemented the interface. Let's do the same thing for a cat. So I will just copy it for the sake of being quick. Let's copy that. Copy, paste. Now let's just change it to a cat. So here this will be a C cat, and it'll be C dot name, and here it will be C cat, and here we're gonna say obviously meow. Okay, so now we have implemented a dog and a cat, which implements the same animal interface. Now let's see what we can do with that. So we can actually so what we have done in the .NET world is we have created an instance of a dog and a cat, put them in an array, and in a for each loop of the array of iAnimals, we are going to call the methods on that thing. So let's do the same thing. So let's create an instance of Rover. Rover is a dog, colon equals to dog. We'll initialize it with a zeroed storage, and then let's create Rover's name, set rover dot name equals to a rover, and let's do the same for a cat, Tubby the cat, and then set Tubby's name to be Tubby. So now let's create an array. So in Golang, to create an array, you will say animals name animals colon equals to. We need an array of size 2 of type animal, and we can straight away initialize the array with references to type rover and Tubby. And we can do a for each loop. So to do that in Golang, so you would say for, and we can ignore the initial verb a, and then say a equals to range animals. So we're gonna range over animals, and then we can do our print statements, fmt.print printf, and I'm doing printf instead of println because I want to do string interpolation. So let's do that. So we are going to say percentage is the animal type, percentage is says the speak thing. So let's do percentage yes again. So the first one would be a.getName, so the animal's name, and we're going to say type. So to do type, we're going to use a package called reflect. So we can say reflect dot get type of the animal, and then the third one is, let's close this, and the third one is the speak, so a dot speak. Okay, so that's pretty much it. So we have created an interface, implemented the interface for a dog and a cat. We created an instance of a dog and a cat. We put them in an array of animal, which is the interface, and we're going to range over them, and we're going to call some methods on them. So let's try this. Go run main.go. Here you go. So it's coming up on the same line. Just let's add a new line statement here. Clear, and let's just quickly do that again. So Rover the dog says bark, Tubby the cat says meow. That's pretty much it. We can stop here, but I just want to go do one more thing. So if you see here, we are doing get name and implementing d.name, and for the cat we are doing get name and implementing the name again. This looks like a repetition of code because we can't use inheritance. We are sort of looks like we are doing it twice. So how do we fix this? So the answer to this question is composition. It's composition over inheritance whenever possible. So we need to compose the name aspect in the dog and the cat. So to do that, let's create a struct called description. So let's say type description, and which is a struct, and it's only going to have a name string. So now instead of using then we can implement the method on this description struct. So here instead of using the dog, we will extend that on this struct. So here you go. Now we can get rid of the dog's implementation of getName and the cat's implementation of getName. And instead of using a name of string, we will basically use compose struct as part of the dog. So we are going to just use description and description. So here we have removed the code duplication by composing description as part of dog and cat. And there is no other code change. So let's just to prove that, we will try this. See, it works as it did. So when you're composing a struct as part of another struct, you are able to use the items in the substruct as if they are as if they are part of the parent struct. So here you can say I can do both to rover dot description dot name. So this and this are the same thing. So I can get rid of description and they are exactly the same thing. When it would matter is if the dog had a name directly in it as well. So let's say if the dog had a name string, then these two things would be different. So then it would, the rover.name and the rover.description.name, they will be two different things. The rover.name would be the one which is directly existing as part of rover, and the description.name would be part of description.name. But if the names are unique across the struct, including the composed structs, then this is an easier way to use the struct. So let's stop for now, and here you go. So we have an interface implemented in Golang which does the same thing we did in C#. Thanks for watching, and please subscribe to continue learning Golang from the point of view as a C# developer. Thank you.